Let's talk about something truly out of this world. Literally. Today we're focusing on a remarkable comet named Atlas, a celestial wanderer that captured the imagination of scientists and stargazers alike. Hello everyone, Bill Nye here, and I'm thrilled to take you on a journey across the cosmos. Today let's dive into the story of a fascinating comet from the far reaches of our solar system, a place where sunlight is just a distant glimmer and mysteries abound. Comets are like giant dirty snowballs, made of ice, rock, and dust left over from the birth of our solar system, over 4.6 billion years ago. These frozen relics are some of the oldest objects we can study, offering a direct link to the early days of our cosmic neighborhood. They're cosmic time capsules, holding secrets about how planets like Earth formed, and even clues about the origins of water and life itself. Now, meet 3I Atlas, discovered by the Asteroid Terrestrial Impact Last Alert System in Hawaii. This powerful network of telescopes scans the skies for objects that could come close to Earth, and in 2019, it spotted something special. When scientists first spotted Atlas, it was brightening rapidly, sparking excitement worldwide. People everywhere hoped it would become visible to the naked eye, a rare treat for skywatchers. As Atlas journeyed from the solar system's edge, it traveled millions of kilometers, carrying with it the hopes of astronomers and amateur observers alike. As it neared the sun, its icy surface began to vaporize, creating a glowing coma and a long, beautiful tail that stretched for millions of kilometers. An awe-inspiring sight in the night sky. But as it got closer, the sun's intense heat and powerful gravity proved too much. Atlas broke apart instead of dazzling us with a grand display. Its nucleus fractured, scattering pieces across space. While disappointing for stargazers, this dramatic breakup was a scientific goldmine. By studying the fragments, scientists learned just how fragile these ancient travelers are, and gained new insights into the forces that shape our solar system. It's a powerful reminder that the universe is dynamic and ever-changing, and even cosmic giants have their limits. Every comet's journey is unique, and each one teaches us something new. So, where did this cosmic visitor come from? Let's travel to the outermost reaches of our solar system to find out. So, where did 3I Atlas come from? To answer that, we have to journey to the very edge of our solar system, far beyond the familiar planets and asteroid belt, to a place few have ever imagined. Far beyond Neptune lies the Oort cloud, a vast, mysterious shell of icy objects encasing our solar system like a cosmic bubble. This distant region is so far away that sunlight is just a faint glimmer, barely reaching the frozen bodies that drift there. It's a cosmic deep freeze, home to trillions of comets waiting for a nudge. These icy wanderers have been preserved for billions of years, untouched relics from the birth of our solar system, holding secrets locked in their frozen cores. Sometimes, a passing star's gravity or a distant planetary encounter sends one of these comets tumbling inward, setting it on a journey toward the sun. This gravitational nudge can alter a comet's fate, sending it on a path that will eventually bring it close to Earth. That journey can take millions of years through the cold, dark void. The comet travels alone, braving the emptiness of interstellar space until it finally approaches the warmth and light of the inner solar system. The I, in 3I Atlas, originally suggested it was interstellar, a visitor from another star. But after careful study, astronomers realized it was actually a long-period comet from our own Oort cloud, making a rare appearance after thousands or even millions of years. Long-period comets like Atlas take thousands of years to orbit the sun, following elongated, unpredictable paths. Unlike short-period comets such as Halley's, which return every few decades, these cosmic travelers may only visit the inner solar system once in a human lifetime, or even less often. These rare visitors are like time capsules, carrying ancient material from the solar system's distant frontier. Each one offers a unique opportunity to study the building blocks of planets and life itself. Studying comets like Atlas gives us clues about Earth's origins. By analyzing their composition, scientists can piece together the story of how our planet, and perhaps even life, began. Some scientists think comets delivered water and organic molecules to early Earth, seeding our world with the ingredients necessary for life. Without these cosmic deliveries, our planet might have remained dry and barren. Every comet is a chance to learn more about our cosmic story. When we watch a comet streak across the night sky, we're witnessing a messenger from the dawn of the solar system, a piece of our own history blazing overhead. They connect us to the grand history of our planet and the universe. Science truly is awesome, reminding us that we are part of a much larger cosmic adventure, one that began billions of years ago and continues to unfold with every new discovery. What if a comet the size of Atlas was on a collision course with Earth? Before breaking up, Atlas was several kilometers wide, about the size of a mountain. An impact at cosmic speeds would be catastrophic, with energy rivaling millions of nuclear bombs. Thanks to telescopes like Atlas, we'd likely have years of warning. Scientists would track its path, confirming the threat long before impact. Imagine the world knowing the exact date a mountain-sized object would strike. The news would change everything, dominating global attention. The impact would fundamentally alter the planet, not just leave a crater. Whether it hit land or sea, the devastation would be global. Let's zoom in on what that day would look like. Picture the moment of impact, even from hundreds of kilometers away. First, an intense flash, brighter than the sun, would ignite fires across vast regions. The heat pulse would arrive instantly, with no warning. Next, a shockwave would flatten everything for hundreds of kilometers, stronger than any hurricane or earthquake. Winds would scour the landscape, and the pressure would be fatal to anything exposed. Molten debris would rain down globally, creating a fiery meteor shower. The sky would seem ablaze, triggering even more fires. Near the impact, survival would be impossible. The ground would vaporize or melt. Massive earthquakes and tsunamis would follow, reshaping continents. It would be the most violent event on Earth in millions of years. In the aftermath, Earth would be unrecognizable. Fires, earthquakes and tsunamis would be just the beginning. A thick shroud of dust and soot would block sunlight, plunging the planet into darkness. Photosynthesis would stop, plants would die, and the food chain would collapse. Oceans would lose their phytoplankton, triggering mass extinctions. The atmosphere would fill with toxic chemicals and acid rain, poisoning water and soil. The air would become hazardous to breathe. Temperatures would plummet as sunlight vanished, causing an impact winter. Even tropical regions could freeze, shocking ecosystems worldwide. Earth would enter a deep, artificial ice age. The impact winter could last for years, even a decade. With no sunlight and freezing temperatures, agriculture would collapse. Survivors would rely on dwindling food stores, facing famine and societal breakdown. People would seek shelter from the cold and toxic air, struggling for survival. As dust slowly settled, sunlight would return, but the world would be forever changed. Mass extinctions would erase entire ecosystems. The last event like this wiped out the dinosaurs 66 million years ago. A comet impact would reset evolution's course. Life would eventually recover, but it would take thousands or millions of years. Hardy species would repopulate the planet, but it would be a different world. Forests and biodiversity would take ages to return. Any surviving humans would emerge into a world they barely recognized. It's a stark reminder of our planet's fragility. That scenario is terrifying, but here's the good news. We're not helpless. Scientists worldwide work in planetary defense, tracking asteroids and comets that could threaten Earth. Networks of telescopes scan the sky every night, searching for moving objects. When a new object is found, it's reported and tracked globally. Astronomers calculate orbits to predict future paths and risks. Most objects pose no threat, but a few require close monitoring. The goal is to find 90% of near-Earth objects larger than 140 meters. Early detection gives us years or decades to prepare. That warning time is our greatest asset. Thanks to science, we're working to keep "what if" from becoming reality. Imagine astronomers spot a comet hurtling toward Earth, and we have a decade to prepare. It's a terrifying scenario, but also a fascinating challenge for science and engineering. What could humanity do to prevent a catastrophic impact? With 10 years warning, we'd have time to plan, coordinate, and act on a global scale. The main objective isn't to blow the comet to pieces, but to gently nudge it off its collision course. Even a small change in its trajectory, if done early enough, could mean the difference between disaster and a near miss. One promising method is the kinetic impactor. This involves sending a spacecraft to crash into the comet at high speed, transferring momentum and slightly altering its path. It sounds simple, but the calculations and precision required are immense. Even a minuscule shift, if applied years in advance, can make the comet miss Earth by millions of kilometers. timing, and accuracy are everything. NASA's DART mission recently demonstrated that this technique works in practice, successfully changing the orbit of a small asteroid in deep space. It's a huge step forward for planetary defense. Another innovative idea is the gravity tractor. Here, a spacecraft would fly alongside the comet for months or even years, using its own gravitational pull to slowly tug the object onto a safer path. It's a gentle but effective approach, especially for objects we spot early. If the comet is especially large, or if we have little warning, a nuclear standoff explosion could be considered. By detonating a device near the surface, we could vaporize part of the comet, creating a jet of material that pushes it away from Earth. Contrary to what movies show, this wouldn't shatter the comet, but would gently redirect it, reducing the risk of dangerous fragments. These strategies give us real hope. For the first time in history, we have the technology and knowledge to defend our planet from cosmic threats. The most important factors are early detection and global cooperation. By working together and sharing information, we can spot threats sooner and respond more effectively. Around the world, scientists and engineers are preparing for the worst-case scenario, just in case. With vigilance, teamwork, and innovation, we're getting ready to protect our only home. So, should you worry about a comet like Atlas hitting Earth? The answer is, not really. The odds of a planet-altering impact in our lifetimes are incredibly low. Space is vast, and such events are rare, millions of years apart. Still, planetary defense is our insurance policy. Just in case. Studying comets and asteroids isn't just about avoiding disaster. It's about understanding our origins and our place in the universe. These icy visitors hold clues to the solar system's formation, and maybe even life's beginnings. When you hear about a comet, think of its incredible journey and the secrets it carries. The universe is full of wonder, and the more we learn, the more amazing it becomes. Stay curious, keep exploring, and remember, science keeps us safe and inspired. Thanks for joining me on this cosmic adventure.